last problem. Okay, so we're looking for the volume. You'll remember this from test one. Alrighty, so we have sine x. Sine x starts at 0, and it makes this little shape right here. We have y is equal to 0, which is along the horizontal, which is along our y-axis. And then we have the interval from pi over 2 to pi, and we're rotating about the x-axis, okay? So first thing that I did was drew my little dotted lines for each of these. And then I put my intervals. So you know that 2 of these little humps is 2 pi, because that's a full cycle, which means this is pi, and then half of this hump would be pi over 2, okay? So that's how we're able to pick this shaded area right here, is because of these 3 pieces of information, okay? It says that it's rotating about the x-axis, so we're rotating along here, which is where this red piece came from. And because there's not an opening in between that space, that's how we know that it's dis versus washer. Okay, and this is the equation that we use for dis. Because we're working with respect to x, we have our r, which is going from left to right, and that's in between our a and our b, okay? So we plug the information in from our a to our b, and then remember with your radius, it's always from the top minus the bottom. In this case, it doesn't really matter because we have minus 0, but I just put it there anyway. And then we have our squared, okay? So for our sine squared, again, remember when we're doing the integration of squareds for trig functions, we actually want to get rid of the squareds to make it easier for ourselves. So here we could use one of those identities that we had from this first chart. So it's even sine, so we go over to even sine, and we are told to use this information. So now, instead of sine squared, I'm now going to write a half, which I put on the outside, and then 1 minus cosine double angle. So that's where this came from, okay? And then from here, I'm able to integrate. So this 1/2 pi combined together gave us pi over 2. When we integrate a number, we just get the variable. And then over here, we know we have cosine, which means we're going to be working with sine. We work backwards. The derivative of sine is positive cosine. That's negative, so that's what we tack on a negative. The chain rule of this would be times 2, but we're doing the antiderivative, so we divide by 2. And then we're evaluating from our pi over 2 to pi. You always do the top minus the bottom. Whenever you do minus, you should always use parentheses. We think it back to our unit circle. Pi over 2, 2 pi is right here. Sine is y, so at this point y is 0, so that goes away. And then over here we have sine of pi. Pi is over here. Again, our y is 0, so both of those go away. This negative goes to that pi over 2. And then to be able to combine fractions, you have to have common denominators. So this pi I rewrote as 2 over 2 with our pi on the top. And then I could combine those two. So I do 2 pi minus pi, which gives us 1 pi, and then we use the same denominator, right? That's just basic algebra. And then we're able to multiply straight across on the top and get a squared pi, or pi squared, and then multiply on the bottom and get that 4.